Hi guys, today we're going to get into circle vocabulary. So there are many things we're going to talk about, many different vocab words I should say. So today our main focus is just vocabulary. So first things first, a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. So the center of the circle is just a point right in the middle. The circle itself then is, let me highlight this, everywhere around that is the same distance from that point. So a circle with center F is called circle F. So that means this point in the middle is called F. And when you go to write that, you just draw a little circle and write the letter F. Okay, next vocab word. A segment whose endpoints are the center and any point on the circle is called a radius. Okay, so a radius goes from the center of your circle anywhere out. So this is a radius, and it should be straight. We just know that I'm really bad at straight lines and straight line segments. A blank is a segment whose endpoints are on a circle. This is what we call a chord, and it's spelled C-H-O-R-D, unlike an electrical cord. So that's just a segment that cuts through the circle, and the endpoints of that segment are on the circle itself. So this is an example of a chord. A chord that contains the center of a circle is called a diameter. So if you have a segment that's cutting through your circle and contains that center, that's what we call a diameter. A line that intersects the circle in 2 points is called a secant. S-E-C-A-N-T. So that's just a line cuts through your circle in 2 points. That is a secant. And a tangent, I'll use blue, I guess. My color choices are limited here. A tangent is a line in the plane of a circle that intersects at exactly 1 point. So it's outside your circle and just barely touches. Let me see if I can get it to actually touch. Nope, that's not good either. There we go. Barely touches the circle just at 1 point. That is what we call a tangent. And that point where it is touching is the point of tangency. So these are all important vocabulary words that we're going to be practicing. Okay, so we are going to walk through an example here and try to identify the best possible vocab word for each of these in this example. So the first one we have here is segment TS. That is right here. We can see that is going right through the center of the circle. So the best possible name for that would be diameter. The endpoints lie on the circle, and it does contain the center of the circle. Next, we've got segment RS, which is right here. That's a segment whose endpoints are right on the circle. So that is what we call a chord. Next, we've got segment OP, which goes from the center out to the circle itself. So the best possible name for that is radius. And lastly, we've got N, which is this line right here, to just barely touch in that circle. So that would be a tangent. Would be the best possible name there. Hopefully you remember what the term coplanar means. Coplanar, remember, means together on the same plane. Co means together and planar means on a plane. So together on the same plane. So two circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles, just like a tangent touches the circle or intersects the circle in exactly 1 point. Coplanar circles that have a common center are called concentric. So together with the same center is what that means. Okay, so if we have common tangents, you can see here we have a circle A and we have a circle B. Hopefully you can see these blue tangents here and here. They're touching A and B both in one spot only. And since they're kind of outside the circles, those are what we call external tangents. The black ones, which hopefully you can see here and here, go in between the circles. So those are what we call internal tangents. And I don't really have a black marker here, so we'll just do internal tangents. So you could have internal tangents for circles and external tangents. Again, those are these two, and the external ones are these two. So in this example, you can see the first one is two circles that do not touch at all. So that one is exactly like the one above. So we were going to have an external tangent here and here. And then we're going to have internal tangents here and here. The one in the middle is just barely touching. So these are going to be tangent circles. So you will have one internal tangent right through the middle. And then again, you're going to have, whoops, try to get this to work. Nope. Sorry, you know how hard it is for me to draw straight lines. We'll say that that works. And nope. Try again. There we go. Two external. So that one has a total of 3 common tangents. And the last one is kind of like a Venn diagram. So there's actually no internal tangents because it would intersect a circle more than once. So this one's only going to have 2 common tangents, and those are going to be your external ones. All right. So theorem 10.1 says, in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint. So if you have a segment, such as this one, intersecting a radius here, and it is a right angle, that means they're perpendicular, and that means AC is going to be a tangent. So if you're trying to say, is something actually a tangent? So we're asking here, is AB actually a tangent? That means we're asking ourselves, is this a right angle? So in order to test that, we have the Pythagorean theorem. We know that if this turns out to be equal, if a squared plus b squared is equal to c squared, then it is actually a tangent. So that's something that we did all the way back in chapter 7. Okay, so if I plug in my legs, it would have to be 12 and 35. The hypotenuse would have to be 37. Okay, so if we test this, if I do 12 squared plus 35 squared, we're going to get 1,369. If I do 37 squared, we're going to get 1,369. So those are equal. So yes, AB is a tangent because it works. The last theorem I want to talk about today is 10.2, and that says tangent segments from a common external point are congruent. So that means that EF would have to be congruent to EG since we're told they're both tangents. So we can use that in this last example to find the value of x. You're told these are congruent, which means they're both tangents. So you're just going to take these expressions and set them equal to each other. Solve that, and you will find that x will be 8. Okay, so you're going to go on to GimKit now and practice the vocab a little bit and then do a self-check on Schoology. Have a great day, guys.